These are notes about molar mass of compounds. We're also going to talk about diatomic molecules and do some calculations. So if you guys remember, we did molar mass already of elements. So for example, like 1 mole of sodium would have a molar mass of 22.99 grams. And if you remember, we can write that as a conversion factor, 1 mole over 22.99 grams, or 22.99 grams over 1 mole, which is going to lead us back to that mole map, and we're going to do calculations similar to what we've done before. Just a few things that I need to cover first. One is, now we're going to be talking about not just atoms on the periodic table, pure elements, but also molecules. And molecules can be diatomic. And what that means is if I ever say that in the room there's nitrogen gas and oxygen gas, which there is, both of these are not monatomic. So you don't just see nitrogen and you don't just see oxygen. What'll happen is they will always find another one of themselves to bond to, and then they become what we call diatomics. So there's 2 of them together. So if you look on the periodic table, the diatomic molecules kind of make a 7, but then hydrogen is also 1. I also have a little mnemonic that I use. And what I say is Brinkelhoff. It's a silly made-up word. Bromine, iodine, chlorine, hydrogen, oxygen, and fluorine. So if I say Brinkelhoff in class, I'm talking about one of these molecules. So if I were to calculate like the molar mass of, let's say, nitrogen, on the periodic table, it's going to say 14.01 grams, or AMUs, and then we convert it to grams. But we have 2 nitrogens. So really the molar mass would be 28.02 grams of nitrogen, diatomic nitrogen, per mole of nitrogen. So I'll show you how to use that more in just a second. So calculating molar mass, that was a really quick one of a diatomic molecule, but let's talk about how to do it for a bigger compound. So barium nitrate. So good practice if you want to pause the video and write the chemical formula for it. That would be the first thing. So let me grab that out of the way. And so barium is +2 and nitrate's -1. So you'll need 2 of these for every 1. So this is the correct formula. And then the next thing that you want to do, and it's just for this test, I'm going to have you show me the work for getting molar mass. So I would list all the elements and how many of each I have, kind of like when we did electron cache. But now, instead of putting the number of valence electrons, we're going to look at the molar mass. So the molar mass of barium is, from my periodic table, 137.33. Nitrogen is 14.01. Can't talk. Oxygen is 16. So when I add all of these, I get something. I just covered up my answer. 261.35. So that's how many grams of it are in a mole. So the unit is gram per mole. You can also, if you guys remember, and I would get out your mole map, remember how we use Avogadro's number, 6.022, 10 to the 23rd. There's that many atoms in a mole. And we can write this, as 1 over Avogadro's number, or Avogadro over 1. And then molar mass here now. So we're not going to just have an element. We could have a compound here. So we would use whatever that value is that we calculate. That there's that many grams in a mole. And then I can write a conversion. If I'm going towards mole, it would be 1 mole over those grams. If I go this way. And if I come back this way, it's going to be grams over 1 mole. So that hasn't changed. I just wanted to remind you of that. So here is an example problem. So I'm being asked, what is the mass? So I'm going here in grams of 2.5 moles. So I'm starting here of oxygen. So I would start with the 2.50 mole of oxygen. And this is where, if you haven't been writing what it is, I would start. So remember, this is one of those Brinkelhoffs. So oxygen is diatomic. So I have to remember that it's O2. So then I'm going to go from mole over here to grams, which means I'm going to multiply by that molar mass of O2. So it's not 16, but it's 32. And then when I do the calculation here, my moles will cancel. I'll be in grams. I'll want 3 sig figs. So I should get 80.0 grams of oxygen. Here's another problem. This will be our last one, but it's a pretty big one. So the first thing we're going to do is calculate the molar mass of ibuprofen, also known as Advil. Advil is the brand name, but ibuprofen is the generic name. And you know, the chemical formula here is C13H18O2. So I would pause the video and I would calculate that molar mass like I just showed you with the barium nitrate. So when you did your calculation, you should have done 13 carbons, 18 hydrogens, 2 oxygens. Molar mass of carbon is 12.01. Hydrogen is 1.01, oxygen is 16. So when I add those, I'm running out of room, but that's what I'm doing. I should get a mass of 206.31 grams per mole for the molar mass then of this big old ibuprofen molecule. So the next question is, if I have a 33 gram bottle that contains 33 grams of ibuprofen, which is the small bottle, how many moles of ibuprofen are in the bottle? So this time, if I'm using my mole mass map, I'm starting at grams, and I'm going to go to moles, and I'm going to use this 206.31 grams per mole as a conversion. So I want to rethink of it as 206.31 grams are in a mole, so then I know I could write it. In this case, I'm going to put the mole on the top and the 206.31 grams on the bottom. So let me show you. Move this out of the way. So I would start with the 33 grams of ibuprofen, and I would always start with that beginning number over 1 or not. Then I'm going to use my molar mass now. So I'm going to grab it, get it out of the way, and I'm going to reuse it. I'm going to put the 206.31 grams of ibuprofen for every 1 mole of ibuprofen. So you don't, in terms of grading, have to put the molecule formula in there, but I would highly recommend that you do it, because again, this is going to build later into more calculations. So the grams will cancel, and I'm in moles. So at this point with 2 cigs, I have 0.16 moles of ibuprofen in that one small bottle. Here's a continuation then of the question. Now they're asking me for how many molecules. I know some of you guys break your problems up into steps, and you can. I could just start with my mole, but I also want to show you that you can do it all in like a one-step problem. If I hadn't previously asked you for the moles, you could look at your mole map, and they want to know molecules. So I would go from gram to mole, and then from mole out here using Avogadro's number to molecules. So I could also just start with the 0.16 mole and have it be a one-step problem, but I'm going to do 2 steps. So I would start with that 33 grams, and I'll just put IB for ibuprofen. The molar mass was, what was it? 20 something. 206.31 in 1 mole of ibuprofen. And then I'm going to use Avogadro. So just reminding you that you can string these together and do it all in one step in your calculator. So there's that many molecules in 1 mole of ibuprofen. So when I calculate this with 3 sig figs, I'm going to come down here. My answer is going to be, or two sig figs, 9.6 times 10 to the 22nd molecules of ibuprofen then in that bottle. But like I said, you could have started with 0.16 mole and gone just that one step, and you would have gotten the same answer. So either way is fine with me. One more question. This one is, I'm being asked for the total mass of carbon only in that compound. So I'm going to do the 33 grams again of the whole big compound, the ibuprofen. And I'm going to convert that to mole again. And yes, you could have just used your moles that you'd already calculated, but I just want to show you it all together. So the molar mass is 206.31. So this will give me the moles. If I stop here, this would be the moles of ibuprofen, which I had already calculated. But now I want to know the mass of just the carbon. So what I need to do is calculate just the moles of carbon. So I can interpret these subscripts as moles. So I can say there's going to be 13 moles of carbon for every 1 mole of the big molecule ibuprofen. So that's something new to us. So we can take these subscripts and interpret them as moles. So if I were interested in hydrogen, I would have said 18 moles of H, or hydrogen, per 1 mole. Or 2 moles of oxygen for every 1 mole of ibuprofen. And then lastly, I want to know the mass in grams of just the carbon. So now I'm going to convert 1 mole. I know that 1 mole of carbon has a molar mass of 12.01. That's why it's really helpful to keep track of which thing you're talking about. So my moles would cancel of ibuprofen, but then also my moles of carbon would cancel. And I'm left with grams of carbon. And with 2 sig figs, because I have 2 to start with, remember all of these are infinite sig figs, then my answer would be 25 grams. So 25 of the 33 grams of that bottle of ibuprofen are carbon.